Here we define the dot product of two vectors. A dot B is a product of the magnitude of A, the magnitude of B, and the cosine of the angle between A and B. And we're going to define, well, this is a definition of the dot product, and we're not going to prove this, but it turns out that the dot product is just the product of the two vectors if we consider these vectors as row and column vectors. I'll put this backward apostrophe on this vector to indicate that this should be a column vector. We regard the first vector as a row, the second vector as a column, and we compute the dot product by just multiplying the row by the column. That is, the first number times the first, the second number times the second. And you see that we get negative 18 plus 3 when we do that, or negative 15. So we've calculated, this is a scheme that allows us to calculate A dot B if we know the vectors A and B. Now, magnitude of A is just the square root of the sum of the squares of its components by the Pythagorean theorem, or the square root of 45. Magnitude of B is the square root of the sum of the squares of its components, or the square root of 10. The definition of the dot product now, well, if we look at the definition, we've got A dot B, we've got a number for that. We've got a number for magnitude of A and a number for the magnitude of B. The only thing we don't have is the cosine of theta. So this means that we can solve for the cosine of theta and thereby calculate the angle theta between these two vectors. The cosine of theta is just A dot B over the magnitude of A, magnitude of B. We just divide both sides over here by these magnitudes, and we just substitute the numbers that we have. Negative 15 over the square root of 14 times the square root of 10, that's about negative 0.7. So that the angle is the inverse cosine of this number. If cosine theta is negative 0.7, then theta is the inverse cosine of negative 0.7, or about negative 45 degrees. And if we want to express that as an angle between 0 and 180, we get 135 degrees. So that this is the angle between the two vectors that we saw over here. And that's a pretty reasonable estimate of the angle between these two vectors. Okay, it looks about right for these two vectors. And to whatever extent, to whatever precision we take the calculation, the angle will be accurate to that extent, to that precision.